During the orientation phase, capsules are oriented with their bodies downward to be prearranged for dosing. Capsules fall by gravity into the feeding tubes where they are randomly oriented with their bodies upward or downward. Held by the capsule release lever, each capsule is released and drops onto the resting blade as the beak holds it in position. As the beaks move upward, the orientation blade pushes each capsule body outward until they are arranged horizontally. The capsule orientation occurs because the internal width of the gauged groove of the drum is larger than the diameter of the body, but smaller than the diameter of the lid. Therefore, the blade push makes the capsules rotate by 90 degrees and orients only its body outward, pivoting upon its lid. The beaks of the feeding tubes move down again, completing the orientation of the capsules with their bodies downward. As the beaks continue their descent, the capsule is held by vacuum as the static pin gently guides it to the bottom of the stroke, at which point the vacuum becomes an air pulse, causing the capsule to drop onto the opening ring. The vacuum is reapplied to hold the capsule in place as the beaks move up. The capsules are then transferred to the in-feed transfer wheel by means of air and vacuum, where they are transported to the opening ring and aligned to the opening holes. As the capsule aligns with the opening hole, air pushes the capsule down as the opening vacuum pulls it into the opening bushing to open the capsule. As the lid reaches one of the slots in the closing unit, it is then pushed downward by the contrast pusher into the corresponding slot. The capsule lids and corresponding bodies are now realigned, facing the same direction as when they were opened in the feed unit. As closing pushers rise, they push the bodies of the capsules into the corresponding lids being held in place by the contrast pushers so as to close the capsules. The contrast pushers continue to rise at the same time as the closing pushers to position the capsule for exit. The capsule is transferred by air and vacuum to the exit transfer wheel as the upper and lower pins move away from the capsule. The wheel then transports each capsule to the exit chute to complete the cycle. The dosing piston travels down to discharge the pellets into the corresponding capsule body underneath, while a soft air pulse helps to move the pellets into the body. As the dosing ring rotates, the dosing piston travels up to clear the chamber area, and then moves down again to form a new dosing chamber for the second pellet type. When the new chamber is positioned under the second sector container, the second pellet type will then drop into the chamber. The dosing piston continues its downward stroke to discharge the pellets into the corresponding capsule body below. The dosing piston then moves up to clear the chamber area, and then moves down again to form a new dosing chamber as the dosing cycle begins for the next capsule. From the in-feed hoppers, the tablets are gravity-fed through chutes directly into the corresponding vibratory containers. Sensors detect the minimum tablet level in the containers and enable charging of the containers with tablets from the hoppers above as required. Through vibration, the tablets are arranged and aligned along the spiral wall of the container and transported upward in an orderly train toward the rotating feed drum. The tablet exit of the vibrating container overlaps the continuously rotating feed drum. A recirculation blower is used to continuously remove tablets from the spiral back into the vibrating container until the feed drum calls for tablets. The rotating feed drum consists of a continuous tablet channel with 4 equally spaced dosing chutes. As the feed drum rotates under the vibrating container tablet exit, the recirculation blower is stopped briefly to permit one or more tablets to be deposited into the continuous channel in preparation for dosing. Upon transfer of the preset number of tablets to the drum, the optically controlled blower resumes tablet recirculation. The tablet deposited into the channel is held in place by a blade as the feed drum rotates. The tablet then drops by gravity along the tablet chute and into the capsule body contained in the capsule bushing belt.